All right. So I've still gotten a few extra questions about our exponents and the different things we talked about today. Oh, where'd my marker go? This is the importance of being prepared with your materials. Hold on. I'm still not sure where all my markers went, but this will work. Okay, so let's talk a little bit about exponents. Again, remember that when we have an exponent, or we call them exponents, the exponent is just one piece of the puzzle though, right? A power, which is a base and an exponent put together, it has two parts. Two parts, right? It's got our base, right? And the exponent goes up here. So sometimes you'll hear people talk about this whole thing as an exponent. That's not correct. I might even say it sometimes. It's a very common thing that people say. But we have a base and we have an exponent, okay? It's two parts and they make up a power. Power! All right. The important thing to know is that the base of an exponent, or I did it. The base of a power, that's the number you see. The exponent tells you how many times you would see that number if you were to write out the 3 times 3 times 3 times 3 times 3, whatever, okay? So, for example, if we're talking about threes, we know that to write out the long version of writing out, let's say 3 to the 4th power is 3 times 3 times 3 times 3, right? We have 1, 2, 3, 4 threes, and we knew that that's what we needed because we have 3 as our base and 4 is our exponent. So we have 3 is what we see, and we see 4 of those. It is all about the base. This exponent just tells you more about the base. It tells you how many bases you're going to have. That's it. It's all about the base. The base is what you see, right? Yeah? Okay. So when we've got 3 times 3 times 3 times 3 times 3, and let me grab my calculator. Okay. So when we have 3 times 3 times 3 times 3, we can sit and do the math out. That's not bad, right? It's just threes, right? But let's use our calculator. I know you know how to multiply. So what we can do is we're going to type in 3. See that? Whoop, 3. And then we're going to find a caret. Little caret. All right. We're going to type in 3, and then the caret, and then 4. Okay, and then hit the enter button. And we get 81. So 3 to the 4th power equals 81. All right, so we can do that. Here also, we know that 3 cubed is 27. We know that 3 squared is 9. We know that 3 all by itself, or 3 to the 1st power is just 3, right? And then we talked in a little bit in our zero exponents lesson that anything to the 0 power is 1, right? And one of the best ways that we can get to that point of understanding, is we know that positive exponents represent multiplication. I don't know if you can see this. I'm going to pull it down so you can see it better. Positive exponents represent repeated multiplication. Write that down. Positive exponents represent repeated multiplication. Woo! Woo! Okay. Woo woo! Positive exponents represent repeated multiplication. What we mean by that is as we increase our exponent number, we're going to end up multiplying, right? So to move from 3 to the 1st power to 3 to the 2nd power, we're going to multiply 3, this value here, by 3 to get the value of 3 squared. We had a total aha moment in class today. I hope I had a light bulb moment, right? So when we go from 3 to 9 here, or from 3 to the 1st power to 3 to the 2nd power, it's getting dark. Ooh, weird. We multiplied, right? We said times 3. We multiplied by our base one time. When we moved up one step, when we increased by one exponent value. So we multiplied by 3 here, and we added 1 here. From 3 to the first power to 3 to the second power, we added 1 to our exponent value. We multiplied by 3 to our final value, right? Yeah? Okay. So, we also talked about, what if we jump 2? So if we increase and we go from 2 to 4, so from 3 squared to 3 to the 4th power, we're going to add 2 to our exponent value. And to go from 9 all the way up to 81, we're not just going to multiply by 3, we're going to do that twice, right? Because we would be multiplying by 3 to get to 27. We would have to multiply by 3 again to get to 81. So we're actually going to be multiplying by 3 squared. So times 3 squared. Or we can write that as times 3 times 3. Or we can write that as times 9. Okay? All different ways to represent the same value. I don't know if you can see that. I picked a really light color. Oh, I'll do better. Okay. Whoop. Okay. So, the other thing we want to talk about is what happens when we go backwards. Okay? And this is where we really start getting more familiar with our negative exponents. So, if we want to go from sorry, I had my previous video papers in my feet. Okay, so if we want to go from 3 to the 3rd down to 3 to the 1st power, when we went up, when we increased our exponent, we multiplied. When we decrease the value of our exponent, what do you think we're going to do? The inverse operation of that. We're going the exact opposite direction, so we need to do the exact opposite operation, right? So to go from 3 to the 3rd down to 3 to the 1st, we're going to subtract 2 from our exponent value, right? And from our final value, to go from 27, come down to 3, we're going to say 27 divided by 3, that'll get us to 3 squared, right? And then we're going to divide it by 3 again, right? And we're going to end up with 9. All right. So, as we then move into our negative exponents, let's talk a little bit about how that's going to look. Stay. Okay. So, we've just talked about how 3 to the 1st power is 3, right? And 3 to the 0 power, just like anything, is 1, okay? So to go from 3 to 1, we had to divide by 3, right? Our action on the exponent was to subtract 1. Our action on the value of our power was to divide by 3, or our base. It's all about the base. Okay, so in order to go from 3 to the 0 power to 3 to the negative 1 power, we're going to need to divide 1 by 3. Okay? 1 divided by 3, 1 divided by 3 is going to equal 1/3. And this is one of the reasons why you are going to love fractions. Because, sure, you can multiply it out or divide it out, you can solve it out, that's fine. But it's going to be a heck of a lot easier for you to just write 1/3. A heck of a lot. Promise. Okay? I'm saving you a step. You're welcome. Okay? All right, so then to go from 3 to the negative 2, from 3 to the negative 1 down to 3 to the negative 2, we're going to take our value here, 1/3, right? Yeah? And we're going to divide, again, by 1/3. Okay? You can also think about this as 3 divided by 1/3. Okay? Whichever way is easier for you. I like to think about it as 1/3. I just bring down the value and then divide it. Okay? So 1/3 divided by 1/3. When we divide, we're not dividing by 1/3, we're dividing by 3. You should have said, Miss Brown, 1/3 is not the base. It's all about the base. You keep saying that. I know. I'm sorry. We're actually going to be dividing by 3. All right? So we take the value of 3 to the negative first power, which we found to be 1/3. We're going to pull it right down here. And we're going to divide it by 3 again. So to say 1/3 divided by 3. Okay, so now we're dividing a fraction. When you're dividing a fraction or dividing by a fraction, you're going to keep your first term, change the operation, and flip your second term. So we're going to keep 1/3, change our operation to times, okay? And then we're going to say 1/3 times, and we're going to flip our 3. So it's going to become 1/3, right? Because we can assume that anything that's just hanging out by itself, there's a 1 around there. It can be multiplied by 1, divided by 1, raised to the power of 1. Like, 1's hanging out somewhere in some multiplicative universe, okay? So you can just pull 1 out and say, hey, 1, I need you to stand right here and help me, look like a fraction, so it makes more sense when Miss Brown is explaining how to flip a number that doesn't look like a fraction, okay? So what that looks like, to draw it larger, is we've got 1/3 divided by 3, okay? We can assume that that 3 is sitting on top of a 1, smushing the 1, okay. So what we're going to do is we're going to keep our first term, right? We're going to change our sign from division to multiplication, and we're going to flip our second term. So instead of this saying 3 over 1, or just 3, it's now going to say 1 over 3. Okay? So now we are multiplying 1/3 times 1/3. Now remember that fractions represent division. Okay? So what we see from this, let's go ahead and solve this out, or simplify rather. 1 times 1 is 1. 3 times 3 is 9. Okay? So the value of the expression, or the power, 3 to the negative 2 is 1/9. Okay. Now, if we were to solve out 3 to the negative 3, we're going to take 1/9, we're going to divide it by 3, we're going to go through that whole process again. So we could write it as 1/9 divided by 3. It's going to end up looking like 1/9 times 1/3, and we're going to end up with 1 over 27. Now, you should be noticing a pattern, okay? You should be noticing that when we were increasing our exponents, we went from 1 to 3. 3 times 3 was 9, times 3 was 27, times 3 was 81, right? Now we're going the other direction. Start again at 1. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9, and that's 3 to the negative 2. 1/9 divided by 3 is 1 over 27, and that's 3 to the negative 3. So what you should start seeing is that 3 to the negative 3 looks an awful lot like 3 to the third power. It's just been flip-flopped, right? Instead of being 3 to the third power, which is 27, we're now looking at 3 to the negative third power, which is 1 over 27, okay? So this is how we know that negative exponents represent repeated division, okay? You can also remember that if you are decreasing your exponent, so when you go down in exponents, you're dividing. When you go up, when you increase the value of your exponent from 2 to 3, or from 3 to 7, or from 7 to 875,000, which is a lot, right? You are going to multiply. When you are decreasing, right? When you go from 3 to 2, or 7 to 2, or -1 to -7, that is going to be represented by division. Are we tracking? in that particular, we're talking about the exponent here, right? The exponent is what affects our base and what affects our value. Okay, so I want to talk about this question because this is one that we almost got to today in class. Explain the difference between 6 to the negative third and negative 6 to the third power. So remember when we were talking about positive exponents, right here, these grouping symbols are telling us that negative and 6 are super attached to each other. They're besties, right? So when we raise this value to the third power, we have to keep that negative right next to the 6 every time we write that base. The base is negative 6, not 6, negative 6. So we're going to say negative 6 times negative 6 times negative 6, right? Negative 6 times negative 6, and negative times a negative is a positive. So we've got 36 times negative 6, which is going to give us negative 216? 256? Hold on. Sorry, guys. Calculator. So 36 times negative 6 is negative 216. I was right the first time. I should go with my gut. That should show you. Go with your gut, guys. All right. So negative 216 is the value of this expression when I simplify this power. Negative 6 to the third power. Remember, negative and 6 are super attached. They're sitting inside of a grouping symbol. They're excluded. They're like, this is our little space, okay? Negative and 6, we're just going to hang out in here. And you can apply yourself to both of us, but not just one. You have to be, you have to talk to both of us. Okay, so here we've got 6 raised to the negative third power. So we can write that as 6 divided by 6 divided by 6. Okay? This is telling us, this negative up here tells us repeated division. So 6 divided by 6 is what? Bueller. I messed up something. We got to think about this as 1 over 6. Listen. 6 to the 0 power is 1. To get from 6 to the 0 power to 6 to the negative first power, we have to divide 1 by 6. I forgot about that. It's easy to do, right? So we have to say 1 divided by 6, and then we're going to keep dividing by 6, okay? So 1 6 divided by 6 is 1 over 36. 1/3 over 36 divided by 6 is 1 over 216. So when we're comparing the value of each of these powers, what you should see is that they look pretty similar. They both have a 216 in there, right? This one is negative because we multiplied a negative number 3 times, an odd number of times, so our final result was negative. And this one is a fraction because negative exponents represent repeated division. And in this case, remember, any number raised to the negative 1 power, any base raised to the negative 1 power is equal to 1 over that base. Okay? So if we have, sorry, I'm having some troubles. Okay. So if we have anything, a base with a negative exponent, with a negative 1 as its exponent, when we write that, we have to think about that as 1 over the value of that base. Okay? B to the negative first power is equal to 1 over B, 1 over your base. Just remember that. Okay? And the way we got there was by going from our 0 power dividing by the value of the base. Anything raised to the 0 power is 1, and then to move from 0 to negative 1, we had to divide by the base, which was 6 in this case. Okay? I hope this has helped a little bit. If you have any other questions, please let me know, and I'm happy to help.